Okay, so when we do this unit, we are starting off with two parallel lines and a transversal. The lines in the picture that are parallel are A and M, and the way we shorthand that, so we don't have to write the word parallel because it is so long, is we say A is parallel to M, and we write it like this: A is parallel to M. A is parallel to M, that's how they write it, shorthand. Since these are our notes, let's go ahead and write this in so we don't forget that's what that means. A is parallel to M. And the way they write that in the picture is they will put like one little arrow on it like that, or they might put two little arrows. And it's not on the end. The arrows on the end are telling you that the line continues forever in each direction. It's them putting it in the middle of the line somewhere, and it's doing it on both lines. That's them telling you that those two lines are parallel to each other. Okay? A transversal is this line. A transversal is a line that cuts across the parallel lines. I don't know why they call it a transversal and not a slanty line. Maybe they're trying to be professional. I'm not sure. So two parallel lines and a transversal, okay? You could have two regular lines and a transversal too. They don't necessarily have to be parallel, but the ones that we are interested in are parallel. Those are the ones where we get all these interesting angle relationships. Okay? Nope, today. Today and tomorrow. After this, we're going to start looking at triangles. Yeah. Yep. Yeah. These are kind of fun. All right, so the first thing is the corresponding angle postulate. The difference between a postulate and a theorem is something that has actually been proven true. Like you could write a formal proof. We're going to get into proofs a little bit later. A theorem is something you can prove to be true. A postulate, you can't quite prove it to be true, but nobody's proven it to be false yet, which means it's most likely true, but we're not exactly positive. Does that make sense? It's like nobody's proven it wrong, but nobody's exactly proven it right either. Kind of that idea. Yeah, it's like some science stuff where it's like, can we go back in time and say without a doubt that it's true? No, because we can't go back in time. But when you like have done the experiments and stuff, does it look like it's probably true? Yes, that's like the idea of a postulate. All right, when two parallel lines are cut by a transversal, that's the picture we have here, the corresponding angles are congruent. What does the word congruent mean? Equal. They are equal in measure. Ooh, congruent. It helps if I spell this right. Congruent. So corresponding angles are exactly what they sound like. So that would be like the upper left angle with the upper left angle of like these two different pictures. So the corresponding angles would be like 1 and 5. And so then angle 1 is congruent to angle 5. Another pair of corresponding angles would be like 2 and 6. Those are like upper right, 2 and 6. So angle 2 is congruent to angle 6. Then we've got like the lower left and lower left are congruent, 3 and 7. So angle 3 is congruent to angle 7. Another pair of corresponding angles would be like angle 4 and angle 8. Those are both lower right, 4 and 8. And so those two are congruent to each other. So they just equal each other. Does that make sense? Cool. All right, the next one is the alternate interior angles theorem. When two parallel lines are cut by a transversal, the corresponding angles are congruent. Not corresponding, I didn't fix that. Oh, dang, I thought I fixed all these. The alternate interior. I swear I did. Obviously, I copy-pasted when I did this, so I don't have to type it every time, but I really thought I fixed that in the sentence. The alternate interior angles are congruent. I thought I was on top of it when I made these notes, you guys. All right, so the interior of the parallel lines, this right here is considered to be the interior because it is inside the parallel lines. Does that make sense? That's the interior, it's inside the parallel lines. So can you tell me what angles are the alternate interior? Yeah, 3 and 6. And can you guys see how 3 and 6 would be the same angle? They'd be the same measure. So 3 and 6 are alternate interior, so that means they're congruent to each other. And then 4 and 5 are alternate interior, so they're congruent to each other. So when they tell you which angles, when they name these theorems, the names of the theorems are like common sense names. They sound kind of formal, but they're very descriptive. Alternate interiors, like, yep, that's probably what I would call that. I might have been a little bit more wordy. I'd be like, you know, in between the parallel lines, but on opposite sides. And they were like, alternate interior. And I'm like, oh, that's a little bit more concise. Good job, guys. Okay, cool, cool. Nice work. All right, the other one is alternate exterior angles. So as you can imagine, if this is on the inside, the interior of the parallel lines, that would mean that up here is exterior. So these are exterior angles, and then down here, these two are exterior angles as well. So alternate exterior would be like angle 2 and angle 7, angle 1 and angle 8. And what do you notice about those? 2 and 7, 1 and 8. They look the same. So, gosh, I typed it again. I copy pasted without fixing it. Alternate exterior. Okay, those are congruent as well. So this is 1 and 8, 2 and 7. All right, go ahead and flip the page. Ms. Rice, are all of the relationships congruent? No. Okay, so next we have same side interior. What do you think they mean by that? Same side interior. Yeah, 3 and 5, okay. 3 and 5, and then 4 and 6. Do those look like the same measurement? No, 3 and 5, you got a little angle, you got a big angle, you got a big angle, you got a little angle. These angles, same side interior, oh look at that, I actually fixed it, are supplementary. What does the word supplementary mean? They make a straight line. What does a straight line add up to? 180. So if you take the measure of angle 3 and the measure of angle 5 and add them together, you get 180 degrees. If you take the measure of angle 4 and the measure of angle 6 and add them together, you get 180 degrees. Okay? So those are all the postulates and theorems we specifically have. But those are not the only names of angle relationships we can see with two parallel lines in a transversal. We have some other ones. They just don't have a special theorem attached to their name, but they basically are special, okay? So one of the other ones is vertical angles. Technically, you're supposed to have learned this before. Does anyone know what vertical angles are? Does that sound familiar? 1 equals 4, 2 equals 3. Does that sound familiar? 1 equals 4, 2 equals 3. So 1 and 4 are the same. 2 and 3 are the same. On this other one, 5 and 8 are the same. 6 and 7 are the same. So vertical angles are congruent. 1 and 4, 2 and 3. There's more than just the ones that we wrote down. Okay? So vertical angles are congruent. In my head, I think of that as the angles on opposite sides of an X. Does that make sense? Because it's kind of like you have an X formed and the ones that are on opposite sides of the X are the same. That's how I think of it. Okay, same side exterior. Can you picture that? What would same side exterior be? 1, 7, 2, and 8. Okay, so same side exterior are supplementary angles. So 1 and 7, 2, and 8. And since they're supplementary, they add up to 180. Okay. And then when I say the word linear pair, when I say those two words together, what would you think those two angles would do? Yeah. What do you think? Yeah, it's a pair of angles that are on Does that give me an example? 1 and 2 would be a linear pair. 3 and 4 would be a linear pair. 2 and 4 would be a linear pair. 6 and 8 would be a linear pair. 5 and 6 would be a linear pair. We got lots of linear pairs in there. So a linear pair is just two angles that are right next to each other and they make a straight line. Okay? So there's lots of them. I only gave you space for 4. So I'm going to say just 1 and 2, 2 and 4, maybe 5 and 6, 6 and 8. Just a few different examples in there. And they're supplementary because they're on a straight line, so they have to add up to 180. Okay. So there's lots of different angle relationships, but they only do two things. Either the two angles equal each other, or the two angles add to 180. That's the only two things they do. So there's lots of different names for them, but they only do two things. Now, sometimes the pictures are really nice, and you can narrow it down, and you can be like, half of these angles are small, and half of these angles are big, right? And then you can be like, cool, if it looks small, it equals the other small angles. If it looks big, it equals the other big angles. Sometimes the angles are so, they almost look like every single angle is 90. Sometimes the pictures look like all the angles are the same. And then you have to actually know what you're doing because they're all like very slightly off, okay? So sometimes you can kind of cheat on this a little bit and you don't quite have to know the angle relationships, but we're going to try to remember the names, okay? And we're going to, once we learn the names, we're going to try to remember the rules, okay? This would be a good thing to make flashcards on, just to say the name of the angle relationship and memorize the name with the picture, and then memorize the name with whether or not it's congruent or supplementary, because there's only two relationships going on here, okay? So now that we know the names, we're going to take those ideas and use whether or not it's congruent or supplementary to solve for the measure of some of the angles of, once you're given one angle, can you find the other ones, okay? So here they said that L is parallel to M, see that little parallel sign? And P is parallel to Q. Now, they told us that information, but they didn't need to. Why did they not need to? Yeah, they marked it in the picture. So some pictures, they'll do the markings in the picture and they won't tell you that they're parallel and it doesn't matter, okay? Now, if they don't tell you in the problem and they don't mark it in the picture, you cannot assume that they're parallel even if they look parallel, okay? So tomorrow, the second day of doing these assignments, we're going to assume that they are not parallel, and we're going to see if there's enough information to prove that they are, okay? So that's a whole second lesson. But for today, they're either going to say that they're parallel or they're going to show that they're parallel before we get started, okay? They're going to say find angle 1 and find the measure of angle 2. And for us to justify this, we're going to say the name of the relationship that we use to justify our answer. Okay? So they gave us this 42-degree angle. Based off of that 42-degree angle, I can already tell what angle 1 is. And what relationship could I use to tell what angle 1 is? Yeah. Complementary. Starts with a C, though. You're right. It starts with a C. Corresponding. Yeah, they're both in the same spot. Top right, top right. So that's corresponding. So we've got the measure of angle 1 is 42 degrees. And that is because of corresponding angles. It is corresponding with the 42. Okay. Now, once I have that 42 labeled, I have enough information to get angle 2. How do I have enough information to get angle 2? Yeah. Yeah, knowing that they are supplementary. Oh, supplementary. I can pronounce that word. Yes. Say that again. Okay, 180 minus 42. And what do I get? 138. And measure of angle 2 and 1 right next to each other like that. What is that called? Starts with it's a linear pair. Measure of angle 2 is 138 degrees, and the reason we know that is because it's a linear pair. And a linear pair is always supplementary because it makes a straight line. All right. Now, just for fun, because this is so fun, let's go ahead and label all the other ones. Woo, we can do it. All right. If angle 1 is 42, what is angle 3? 42, and why? Oh, yeah, you can say alternate exterior because of this 42 up here, right? That's alternate exterior. That's why it's 42. Okay, you knew that 8 was 138. Why? So you can't, so this 8, you can't use 2. This 42? Okay, so using this 42, you can say that 8 is 138. Why? Same side exterior. Same side exterior have to add up to 180. Okay. All right, what else could we say? 6 would be 42. Why? Because these two, it's a linear pair. Okay, linear pair, they're supplementary. Okay. What else can we say?
7 is 138.
Okay, why?
Because,
Say it again. Alternate interior with what? Not with, so with, if you said it, if you had a relationship with 8, that would be vertical angles. So you could say 7 and 8 are the same because they are vertical angles. That's exactly right. So it's 138. Okay. Now, if we wanted to do alternate interior, we could say that 4 and 7 are the same. Those are alternate interior angles. Okay. Okay, vertical angles 4 and 5 are the same because they're vertical angles. Okay. Did you guys see how it was almost a domino effect? One leads to the next, leads to the next, leads to the next. Okay, so when you do pictures like this, that's pretty common to be able to have a domino effect. One thing leading to the next thing, leading to the next thing. Okay, for the next one, did they need to tell us that L was parallel to M? Did they have to say it? Nope, they showed us in the picture. All right, they want us to find A, B, and C. I want you to find, we're going to find B, but we are not going to use the fact that there's a triangle in that picture. So we are not going to say that the three angles of a triangle add to 180. We're not going to use that, okay? That is off limits. It is off limits. Okay, so what can we do? Any ideas? Yes. Okay, how did you know? Not corresponding. It's an angle relationship, but it's not corresponding. It's not vertical. It's alternate interior. So if you picture this right here, if you would take this and you extend it a little bit, this would be the transversal, and this is the inside of those parallel lines. And so what you have here, these are your alternate interior angles. Do you guys see that? So that means that C is your 40-degree angle. There you go. Okay, and what's our reasoning there? Same thing, same thing. Same thing, okay, so here's our transversal. We got the inside of our parallel lines, right? There's the inside of our parallel lines. These are alternate interior, so they're the same. Yeah, and it's at this point, it's kind of, we don't really have a name for this angle relationship because it's 3 angles instead of 2. We could call it a linear triple if we wanted. It's the idea of a linear pair, but it's not 2 angles, it's 3. So, I know, but we're not. I told you guys couldn't use the fact that it's a triangle. We're not because we found A and C instead of just adding the 2 down here together. Okay, so we got 180 For the straight line, we're ignoring the fact that it's a triangle and we're just using the straight line. Minus 65, minus 40. I wanted you guys to use those alternate interior angles instead of saying it was a triangle, so that was good. All right, minus 65, minus 40, what do we get? 75. All right. Cool. So I know the names of the angle relationships are a lot, so we're going to have to keep our notes out today, right? It's a lot. It's a lot to have in your brains. Okay, let's go down to the next example. So in the picture here, they did not tell us the lines are parallel. Do we have enough information in the picture to know that they are? Yes, they did the little labels for us to show that they're parallel. Okay. Now, if you look, there's two variables happening here. There's an x variable, there's a y variable. Whenever that happens, you're going to look to see which, because there's three pieces of information. So where we're going to start is we're going to look for two pieces of information with the same variable, okay? And that's the angle relationship we have to start with. So if I look here, I can see like, oh, this could be alternate interior angles, but that's two different variables. Do you guys see that? I see, ooh, this could be a linear pair, but that's two different variables. So I'm not going to use either of those angle relationships. Does that make sense? Because that's not helpful. Those are two different variables. That's not the easiest way to do the problem. The easiest way to do the problem is to start with this angle and this angle because those are the same variable. So that's going to be the easiest way to do it. It would be same side interior, and someone other than Jack, I'm so sorry, Jack. Someone other than Jack, tell me what is the relationship between same side interior? They're supplementary, they add up to 180. Okay, so I'm going to say 6y plus 13y minus 10 equals 180. Now, the biggest way that I notice students messing up problems for this particular assignment, this day of work, is they just mix up one to add to 180 and one to equal. That's the biggest thing, is they just mix up what's congruent and what's supplementary. So just keep that in mind, is that's pretty much the biggest mistake you can make today, is mixing those two things up. I should make a baby animal for that. I will work on that as soon as you guys get started, print it off and put it on the board. All right. What do we do first?
Well, 6y plus 13y minus 10 equals 180, then you can divide the 6 by 180.
I wouldn't divide by 6.
Then you get 19y.
I would combine like terms and get 19y. There we go. I'm sorry, Jack, you were so sure. All right, then what do you do? Add 10 to the other side. Okay, Jack, you know this part. You know this part. Yeah, you do. Yeah, you do. No. What step are you going to do to get the 10? Divide by 19. It's the divide part. This is the divide part. Okay. Yeah. Okay, y is 10. Okay, so we got one answer. All right, now, do I take y is 10 and say, all right, this is 10, this is 10? Is that how that works? No, what do I do with the 10? Plug it in. Okay, so which one do you want to plug it into? 6, that's easier. Okay, 6 times 10. 60. Okay, so if this is 60, what's the other one? 120. Okay, that was a little bit easier than plugging it into the other one. All right, now what relationship would you guys like to do to figure out the x's? Because we said we could do alternate interior, or we said we could do linear pair. And those are slightly different processes. You want to do linear pair?
Yeah.
Okay, so if we do linear pair, how are we doing that equation? So we're going to say 9x plus 12, and then what else? Plus 60. 9x plus 12 plus 60 equals 180. Okay. So that's the linear pair way. If you did the alternate interior, then you would say 9x plus 12 equals 120. That would be alternate interior. Okay. All right, so I'm going to combine my like terms. I get 9x plus 72 equals 180. And I'll subtract my 72. 9x equals 108. And then what do you guys get? 12. All right. Next example. Okay. So here we've got 3 different variables, but none of the variables are repeated. So when we have something like this, our strategy is going to be to look. We can see that we are not going to do these two together. We're not going to do same side interior because that's 2 different variables, right? So we're not going to do that. Why are we not going to do these together beside the fact that they have 2 different variables? It's not a relationship. There's no name for that, so we don't know if they're supposed to be congruent. We don't know if they're supposed to be supplementary. So I'm not going to do that one. I'm not going to do this one for the same reason. So whenever you have something like this, what we want to do, the key that we're going to use here is the fact that one of them has no variable at all. Does that make sense? So the 98 is the one we want to use. So if you have a problem where you have 2 variables, you either stick the same variable with the same variable, or you find an angle that has no variable at all, and then you use that one. Does that make sense? So we just make sure that whenever we do a problem, we don't try to mix 2 variables together on the same one, because then we get very confused. Okay? Which angle relationship would you guys like to start with? I can see that we could do the z first, or we could do the y first, depending on what angle relationship you would like to use. They did say we do need to mark our parallel stuff because they did not mark the picture for us, so that we have to use the description. They said that L is parallel to M, so we do have that. And they said that C is parallel to D. So we do have that, so that's good that they told us that. Okay, so do you guys want to solve for Z, or do you want to solve for Y? Z, okay, and what angle relationship do we use to solve for Z? Alternate interior. Okay, alternate interior. What do we know about alternate interior? Are they supplementary or are they congruent? Congruent, they are the same. So we're going to say 98 equals 14Z. And then how do we solve that equation? Okay. You did 14Z plus what?
82 because.
Oh, you can do that. So you said. Yeah, you can do that. Sure. Sure. You can do that. Yeah. So what you guys are talking about is like kind of using the idea of the domino effect of like starting to like use the 98 to fill in other stuff and then maybe use an angle relationship you're more comfortable with, which is absolutely fine. You can totally do that. Yep, that is totally fine. So 98 divided by 14 is what? 7. 7 equals Z. Okay, well there we got 1. Okay. Do you guys want to fill in, since some people suggested they did that, do you guys want to fill in some more of the angles that we know? Okay. 3y plus 8 is 98. How do you know? It's alternate exterior. So these two are the same because of alternate exterior. Hold on, my screen's going to fall asleep. There we go. Alternate exterior, they're congruent, so that means that 98 equals 3y plus 8. Okay, so I'm going to go ahead and minus the 8 over 90 equals 3y. And then what should I do? Divide by 3, and y equals 30. Okay. All right, and then how did you guys solve for x?
Corresponding angles, because 98 is the one above 2x plus 6.
So this is 98, this is 98, because these two are corresponding. Okay, and so this is 82, that's what you meant?
Yeah.
Uh-huh.
And then, 2x plus 6.
And then those are the same because vertical angles. Okay. Okay, so then we'll say 2x plus 6 is 82. So 82 subtract 6 is 76. And then divide by 2. X equals 38. Okay, the reason I kept the last two examples is because I hate pictures like this. I think it's very hard with a picture like this to see the two parallel lines in the transversal. So one trick that I do is I extend the lines. Here's my two parallel lines, here's my transversal, and once I do that, it makes me more comfortable. I might even get white out and get rid of this line over here. Now it's more comfortable because it reminds me more of what I'm used to seeing. Does that make sense? Okay. So I do not need to mark my parallel lines because they're already marked in the picture. I can see that two angles already have an x in there. One angle has a y. So what angle relationship am I going to use for the two angles that are labeled with an x? Same side interior has an x and a y, so I can't do those. The two with the x's, what's the relationship between those? Corresponding, yep, top right, top right. Do you see it? Top right here, top right there. So what do we know about the two angles with an x in them? They're going to be congruent. Okay, so I'm going to use corresponding. That's the relationship with the x's. So I got 4x minus 5 equals 3x plus 11. So I'm just going to pretend that I got rid of this because it's not helpful in the picture. Okay, so what should I do? So x minus 5 equals 11, but don't subtract the 5 over. What should we do with the 5? Add the 5. It was a typo. You meant to add the 5, right? Okay. So x equals 16. And then what should we do with that? Plug it in. Okay, which one do you guys want to plug it into? Yeah. That's fine. Which one do you guys want to plug in the 16 to? It doesn't matter. They're going to be the same regardless, right? 3x plus 11. All right. 3 times 16 plus 11. And then what do you guys get when you plug it in? All right, cool. So this equals 59. So we got 59 here, 59 here. And we have a couple options for what angle relationship we can use to get y. Which one would you guys prefer to use? So you just said this is 121. So you kind of use that idea of the domino effect to figure out what your angle was first, and then you didn't even worry about using an angle relationship. So you actually technically did linear pair, even though you didn't really think of it that way, because you were like, I know that two angles make a 180-degree angle. Does that make sense? So you use the idea of linear pair first, and then you were like, now I'll go ahead and solve the equation. Okay, so perfect. We got this. And now let's do 3y plus 1 equals 121. And how do we solve that? Minus 1. 3y equals 120. Divide by 3. Y equals 40. All right. Marvelous. Okay. Next picture. Now, I would argue before we even mess with the fact that we've got two parallel lines, we can already find y. How could we find y? 180 minus 63. And what are we actually doing here? Linear pair. So linear pair doesn't need to have two parallel lines in a transversal. That can happen anywhere you have a straight line. Okay. Now, how can we fix this picture to feel a little bit more comfortable for us? Yeah, I'm going to extend the lines. Now, should I extend this line right here? No, because it's not connected to the x. So I could extend that one, but it's probably going to confuse me. Okay, so I'm going to extend my parallel lines for sure. I'm not going to extend that one. It's not very helpful. I am going to extend this one, though. Okay, and honestly, I might even get rid of this at this point because I know why now. I'm going to get rid of this because it's not helpful. Okay, what do you guys notice now that we've gotten rid of the extra stuff? Yeah, x is 56. It's kind of obvious now. What relationship did we use to get x equals 56? It's not corresponding. What is it? Alternate interior. It feels like it's corresponding because it feels obvious. But remember, corresponding is that they're in the same like space. They're upper left, upper right, lower left. And these are they're not in the same space, but they just feel like they should be the same measurement. Yeah. All right, how do we feel about these? Good? Okay. You are going to want this out to be able to do the next activity, okay? So to do the next part, you're going to need you're going to need a blank sheet of paper out. Every single person needs a blank sheet of paper, but you're doing the activity together as a group. It's just that every single person needs to show their work, okay? So blank sheet of paper. If you don't have blank paper, go ahead and come up here and grab some. I do have notebook paper up here. All right, here is how the activity is going to work. Everybody's going to start on card A. You do not have to draw the picture, but as I was going through the problems, there were some pictures I did have to draw so that I could label things and do it. Please don't draw on these cards. They took me forever to cut out, so if I teach this class again, I do want to use them again. So don't draw on these. So something like this, you probably need to copy the picture down on your paper, but definitely every single person should be writing. Problem A is the one I start with. This is the equation I'm solving. Do the work on your paper, and that's how you're getting credit for participating in the group assignment. Does that make sense? So if there's 3 people in your group, 3 people are turning in their own work for the problem, but you guys are doing the work together. Does that make sense? You're all talking through it. Most of the problems are pretty okay. About 2/3 of the way through, there are a couple problems that get a little hairy. They get a little woo, this is a difficult problem. So when you get there, if you're having a hard time, let me know, okay? And then after you get through the tough spot, it gets easier again as you get closer to the end, okay? So it's not going to go in alphabetical order. If you're going in alphabetical order, I can guarantee you're doing it incorrectly. When you get your answer for what A equals, then you're going to look through the cards, and that's going to help you figure out what card to do next. Because at the top of the other cards, it says previous answer, and that will help you determine what letter comes next. Does that make sense? Okay.